this video, we are going to solve this question I have on the screen. The question says a fixed crane has a mass of 1000 kg and is used to lift a 2500 kg crate. It is held in place by a pin at A and a rocker at B. The center of gravity of the crane is located at G. Determine the component of the reactions at A and B. Okay, so that's the question. One thing you have to know is that this question is under equilibrium of rigid bodies. Okay, so we are considering the system to be in equilibrium. So if the system is in equilibrium, that means it is stable, and then the sum of all the forces acting on it must balance each other. Okay, so you are going to see that the sum of the forces in the x-axis should be equal to 0, and then the sum of the forces in the y-axis should be equal to 0. Okay, and then if there are moments also, the moments will be equal to 0. So let's look at what you are going to do. So one of the first things you will have to do with this question is to draw the free body diagram. Okay, so I have my free body diagram here, and then I'll indicate the reaction forces. So because we have a rocker here, okay, the rocker can slide vertically, okay, but it can't slide horizontally. So you are going to have a reaction force in the x-axis direction, which I have indicated as bx. And then for the pin joint, we can't because of the pin joint, okay, we can't move the crane at this point here in the vertical or the horizontal direction. So that's as a result of reaction forces that will be in those directions. So I've indicated those reaction forces with AY and then AX, where AX is the reaction force in the x-axis direction, and then AY is the reaction force in the y-axis direction. Okay, so that's all about the free body diagram. Okay, so let's go what we're going to do next. So you know the center of mass, okay, of the crane, right? So that means that that's where the weight of the crane will be concentrated. Okay, so you're going to have the weight to be equal to 1000 kg multiplying acceleration due to gravity. Okay, so that gives us the weight. Okay, so let's look at what you are going to get for the weight. You are going to have 1000 times 9.81. Okay, that gives us a value of 9810 Newton. Okay, and then you have another weight here, okay, which is 2500 kilograms. So that one also, let's name this as WB, okay, weight of block. Okay, that should be equal to 2400 times 9.81. Okay, so let's find the value of that. 2400 times 9.81. That also gives us a value of 23,544 Newton. Okay, so that's the weight for the block. Okay, so now we want to find the reaction forces that will help keep the system in equilibrium. Okay, we want to find the reaction forces that will help keep the system in equilibrium. So in doing this, we are going to consider the equilibrium equations, which will be some of the forces in the x-axis should be 0, and then some of the forces in the y-axis should also be 0. And then in this case, you have a pin joint, okay, and then you see that this system is in equilibrium, which means that it is just stable, it is not rotating or moving. So that means that the sum of the moments should also be equal to 0. Okay, and then the only point of rotation is point A. Okay, so the sum of the moments about point A must also be equal to what? 0. So those are the equilibrium equations we are going to consider. So let's go ahead. Alright, so now let's consider some of the forces in the x-axis direction. Okay, so for the sum of the forces in the x-axis direction, for the forces in the x-axis direction, you have just two, which is ax and then bx. So you are going to have, for the sum of the forces in the x, you are going to have ax, okay, plus bx is equal to 0. So for the direction of the reaction forces, okay, they are random. Okay, you just have to decide your direction. Okay, so first there is a reaction force, then you have to decide your direction. So at the end of your calculation, the sign of your answer will tell you whether the reaction force is in the negative direction or the positive direction. Okay, so for bx, I chose the positive x-axis direction, ax, so I chose positive, and then ay, I chose negative y-axis direction. So if at the end of, for ay, for example, I choose the negative direction, so if at the end I get my answer to be positive, that means it is rather the positive direction, not the negative direction. So for the direction of the reaction forces, you have to choose them. Okay, when drawing the free body diagram, your answer will actually confirm which direction that it is in. So let's continue. So that will be our first equation. Okay, let's consider the second one, which will be some of the forces in the y-axis direction. Okay, some of the forces in the y-axis direction. So for that one also, let's see what you have. You're going to have minus ay, right? And then minus ay, then you're going to have minus w, right, which is the weight of the crane, sorry, and then minus wb, right, which is the weight of the block, and then this should be equal to 0. So I'm going to have minus ay, okay, minus 9810, right, minus 23544, and all this should be equal to 0. This should be our equation 2. Now let's consider the moment about point A. Okay, let's consider the moment about point A. Okay, so for the moment about point A, you know that AX and AY are acting directly on point A, so their moment will be 0. Okay, so some of the moments about point A, since AX and AY are acting directly on point A, their moment will be 0. So let's look at BX. So for BX, okay, let's consider clockwise moment to be positive, and then counterclockwise, okay, counterclockwise to be negative. Okay, so b, okay, bx will cause momentum at point A, and then that will be in this direction, which is the counterclockwise, so we are going to make it negative. So that will be minus 1.5, okay, bx, because its perpendicular distance from point A is the 1.5. And then let's look at the moment that will be caused by the center of mass, okay, which is the weight of the crane. So for that one also, its perpendicular distance will be these 2 meters here, right? Because this is the line of action of the weight force, and then its perpendicular distance from point A will be the 2 meters, okay. So for that one also, we are going to have plus 2, okay, multiplying 9810, okay, and then that will be a clockwise moment, so that will be positive, right? And then same for the weight of the block, that will also be a clockwise moment, and then its perpendicular distance will be 2 plus 4. Okay, so you're going to have plus 23544, okay, multiplying 2 plus 4, which will be what, 6. Okay, so all this should be equal to 0. Okay, so let's simplify this. Okay, let's simplify this and see what you're going to get. So if you simplify this, you're going to have minus 1.5 bx, okay, plus 2 multiplying 9810, right, plus 23544 multiplying 6. That gives us a value of 1 6. That gives us a value of 160,884, okay, equals what, 0. So this is our equation 3. So you have 3 equations, but you can see that you can solve 2 of them directly, right? You will not have to do any simultaneous equation here. So you notice that if you solve equation 2, you're going to get ay, and then if you solve equation 3, you're going to get what, bx. Then you can substitute bx into equation 2, so into equation 1 to find what, ax, right? So let's look at that. So let's focus on equation 2. From equation 2, you're going to have minus ay. Okay, I already have equation 3 ready, so let's finish equation 3. Okay, so from equation 3, I'm going to have minus 1.5 bx, okay, to be equal to minus 160,884, right? So now let's divide both sides by minus 1.5 by minus 1.5. Okay, so this will cancel out this. Let's see what you're going to get for bx, which is the reaction at point B. So you're going to have minus 160,884 divided by minus 1.5. That gives us a value of 107,256 Newton. Okay, so let's change this to kilonewton and see what you're going to get. So you multiply our answer by 10 to the power minus 3. Okay, and then that'll give us a value of 107.26 kilonewton. Okay, that's for bx. Okay, now let's find ay. So for ay also we have minus ay minus 9810 minus 23544 equals 0, right? So let's simplify this. So I'm going to have minus ay to be equal to 9810, okay, plus 23544. Okay, that'll give us a value of 33354, okay, Newton. Okay, so we're going to have ay, okay, to be equal to minus, okay, 33354. Okay, so you got negative, okay, which means that the direction you chose is correct. Okay, which means that the direction we chose is what? Correct. Okay, so you can choose any direction for the reaction forces. Okay, your answer will confirm that. Okay, so if you look at Vx also, we chose the positive x axis direction, then you got a positive answer. Okay, so that also confirm that that's our direction. And then if you choose the negative axis direction also, the answer will have to confirm it. So now let's look at ax also. So we know that ax plus bx should be equal to 0, right? So we are going to say that ax equals what? Minus bx, right? So that will be equal to minus 107.26 kilonewton. Okay, that will be the value of what? Ax. So that means that ax is actually moving in the negative x axis direction, not the positive x axis direction. Okay, so that's what it means. So let's change ay also to kilonewton. We have minus 33354 times 10 to the power minus 3. Okay, that'll give us a value of minus 33.35 kilonewton. Okay, so you see that after the calculations, we found out that bx is still in the positive x-axis direction. That will be the direction of the reaction force, and then ay will be in the negative direction. Okay, and then ax will rather be in the negative direction. But at the beginning we chose the positive direction, but after the calculation we found out that it is actually in the negative x-axis direction. Okay, the signs just means the direction. Okay, so it doesn't really affect your answer. Thank you very much for watching this video.